So we're on page 11. The last thing we need to talk about in this section is margin of error. A lot of times when people construct intervals, they'll have a specific margin of error in mind that they want to keep within. And so what they'll do then is they'll try to figure out how big of a sample do I need to stay, sample size do I need to stay within that margin of error. So that's what we're going to do. So what is the formula for margin of error for a confidence interval for proportion? This you guys should already know. Formula for okay, first of all, what is the margin of error in a confidence interval? Okay, wait, pause. That was a poor question. What is the formula for a confidence interval for proportion? Whole formula. Yeah. Okay, so this is the formula for confidence interval for proportion, the one that we've been using. What part of that is the margin of error? All right, everything after the plus or minus. What is this called? I'm not looking for proportion. It's a point estimator. It's a statistic. So it's always a point estimator plus or minus the margin of error. So this is the formula for margin of error. That's always going to be the case. It's always everything after the plus or minus. So even when we learn new formulas, everything after the point estimator. What is it called when you take away the z? What's just the square root called? Do you remember? Standard error. Standard error. Okay, is this formula on the formula sheet? No, it's not. But again, the formula sheet's in words, so you should be able to figure it out. Oh, okay. So, like I said, a lot of times you're going to be given a certain margin of error, and you're going to have to solve for a sample size. Now, how do you know what p hat to use? There's three kind of rules that we go by. So if you're the one who's actually carrying out a study, what p hat do you use if you haven't carried out the study yet? You could use a previous value. So it might say something like, previously, the proportion of people with brown hair was 0.3. So that's what you're going to use. Sometimes statisticians will take a small study, a pilot study, and use that sample proportion before their bigger study. So you can use a pilot study. These two are going to be worded exactly the same. It'll just say something from a previous study, from the past, it's believed that, something like that. Okay, let's say you have no information at all, no previous studies that you can go by. You're going to take p hat to be 0.5. So if you have nothing to go off of, you're going to use 0.5. Okay, so here's how you're going to see a question. Suppose that you wanted to estimate P, the true proportion of students at your school who have a tattoo, with 98% confidence and a margin of error of no more than 0.1. How many students should you survey? So first, you're going to set up your margin of error. We want it to be no more than 0.1. So this is our margin of error. We want it to be less than or equal to 0.1. And then you're going to fill stuff in. Where am I going to find the z? Calculator or table. I'm going to do the table since we already know how to do the calculator. This is what we did Friday. We talked about using the T critical values table. You guys remember this? Go all the way down to the bottom, 98%. You use the number right above that, 2.326. So this will be 2.326. We're solving for n. Okay. What are we going to use for p hat in this case? Sorry, Alex, yes?
Is there a reason you always write 0.10, like in there and also in the n less than 0.1?
No. No, like why use 0.10 versus just 0.1?
Yeah.
No reason. Yep, just for fun. Okay, what are we going to use for p hat? Do they give us any sample proportion at all to go off of? No, right? No. So you're just going to use 0.5. 0.5 makes this numerator a maximum. So this gives you the largest sample size you need. So it's a conservative estimate. Okay, you solved this. So take out a calculator. Is your calculator done?
Yeah. Thank you.
You're welcome. Once you have a sample size, compare with the person next to you to see if you guys agree.
Dude, wait, how do you like? How do you use the answer thing?
So second, enter.
Oh, whoops. Okay.
Okay, some of you are really good at this. Some of you, your algebra skills are not amazing. And what's the first thing that you should probably do?
I'm just really kidding.
I would divide by 2.326 first. So that ends up being 0.25, and then whatever that is. No. Okay, then square everything. So you're going to square that, so you end up with 0.25 over n. It's less than or equal to 0.1 over 2.326 squared. Ultimately, you're going to multiply by n and divide by whatever that quantity is. So you're going to get n is greater than or equal to 0.25 divided by that whole thing, which is 135.26 about. Okay, here's what's really important. You must show this. Now, is it possible to have a sample size of 135.26? No. So what is the smallest sample size that we would need? It says n is greater than or equal to that. So you never round down. You're always going to round up. On the AP test, if you do not show the decimal and round up, you're going to lose a point. That's a big point, so please make sure you round up.
So is this rule why, so like whenever I seen like the news, like a survey, like when they mention like a survey with n equals some number and the number's never like an even number, like 150, it's always like 237 or like 1,430, like some weird number.
Yeah.
Is this the reason for that, or part of it?
Could be. My guess instead would be that they had a round number for their sample, but then didn't get responses from everyone. Or they got responses that they couldn't use. That would be my guess. Emma?
Do you have to show the like math behind it or just
No. So I want to see this, that, here, and then those two. If you want to show the math, you are welcome to, but I don't require that. Sound good?